Yeah, this is good. Okay, perfect. So like I said, I'm Alyssa, I'm the campus manager, and I'm going to go over the first day of class, getting started information, and then I'll be passing it over to your instructor for introductions between you guys and the first day of class. So first of all, welcome everybody to Miami Cybersecurity 3. This is 4Geeks Academy USA's third cybersecurity cohort. We originally launched the program in Spain, and it's been running there for about 2 years now. It's been doing very well. So about, 6-7 months ago, we decided to move everything into English and USA, and we moved it over here. And now we're on our third cohort, which is you guys. So our start date is today, January 6th, and our estimated end date is May 7th. The cohort always starts on a Monday and ends on the very last Friday. It is estimated based on 16 weeks of classes, which include your final project, and any holidays are taken into account. That's why we decided to start today instead of the 20th of December, because if you met 1 week, we would have had 2 weeks off for break anyway, and then came back today. So Cody here, who started the recording, he is your instructor. Some more of the 4Geeks team that you may have already met or will be meeting. Laura is the program manager, so she's in charge of everything related to your student experience. So any challenges you face, whether it be directly with your like studying, or it could be personal things, like for example, sometimes students have, deaths in the family or something like that, and that obviously interrupts their study. She is the person who you can always go to, and she can help you if any of that kind of stuff happens to you. Then you will see various mentors here throughout. So one of the perks of being a 4Geek student is that you do get unlimited one-on-one mentorship for your curriculum and unlimited one-on-one career support mentorship. So the ones that just say mentor are the ones who are either full stack data science or cybersecurity mentors. And then the ones that you see that say career support are some of our career support teams. So we help you with your resume and your LinkedIn. And we have 2 actually more chances to talk about career support coming up. Then you also see me. There's Alyssa, campus manager. And then you'll see our 2 co-founders, Marcelo and Alejandro. Marcelo, he is the kind of like business side behind the operation. So he is admissions, student services, career support, finance, this kind of operational side of things. Whereas Alejandro is the more technical. So he creates the syllabuses, he does the tests, he does the GitHub pull requests, everything related to that side. He actually built the 4geeks.com platform and the Learn Pack that you use and all of that live feedback. Now they're with an AI. They call him Rigobot. So he's always, building these things for 4Geeks. So we talked briefly about the unlimited one-on-one technical mentorship and the unlimited one-on-one career support mentorship. So we call those 2 Geek Pal and Geek Force. Geek Pal is your unlimited one-on-one technical mentorship. So there's 3 ways that you can, or 2 ways that you can get help as a cybersecurity student. You can message in the group that's called Public Support Cybersecurity inside Slack that has all of the cybersecurity students and alumni in it, all the professors, all the cybersecurity mentors. So it's like a live community of just people helping people with their questions. And then you also have the one-on-one mentor sessions that you can schedule in 4geeks.com. You can choose the mentor that works best for you, the schedule that works best for you, and book those sessions to help you with anything you need related to class. Those are unlimited and you can use them as much as you need. Then on the same kind of token, but on the career support side, we have Geek Force. So Geek Force is our career support track, and it's our promise to you that we're going to do everything in our power to help you get a job. So it works in 3 stages. We do have Patricia here in the meeting, and she is going to go a little more in depth into it after I finish up my presentation. But basically, we help you with your resume, your LinkedIn, your portfolio, your mock interviews, everything that you need to be ready to apply for and land your first job. Valentina Ancieta, she is our head of career support. We also have 2 other Valentinas on the team, which are Valentina B and Valentina J. And then we have Patricia, who unfortunately was not named Valentina. So we just have 3 out of 4. And then what a typical week looks like at 4Geeks Academy. This is actually incorrect. This is our full-time schedule, so please ignore what it says. But your class meets Mondays, Wednesdays, and Fridays from 6 p.m. to 9 p.m. So that will always be the schedule. It will never change. It's always going to be the same meeting link. It's always going to be the same classmates, the same teacher. This is your class. Then outside of class, you can book those sessions with our mentors in 4geeks.com. We recommend that most students need to put in between 20 to 24 hours weekly, including class time, in order to succeed. So your class already meets 9 hours per week, so you should plan to put another 11 to 15 hours of your own time. That's working on projects, reading, studying the material, maybe joining mentoring sessions. All of these things count towards your time. We don't time you. We don't need you to clock in or out. We don't need you to report your hours to us. That's not what we mean. We're just telling you what we've seen in the past that most students, need to set aside or need to be able to commit to in order to keep up with the workload and succeed in the class. Otherwise, you are more likely to fall behind. Some students work faster than others. If you finish it all and you don't need to put in that extra time, that's okay. If you need more time than that, that's okay too. This is just a recommendation. Cody, you have a comment?
Yeah. So I'm sorry, I'm new to all of this. It's great to meet you all. But so the one-on-one sessions, are those for like study sessions? Are the mentors going to help train and provide feedback on the curriculum, or what's the goal of the mentor specifically?
Correct. So the mentor sessions are very flexible. It's a one-on-one meeting. So it would be the student and the mentor. The student can ask any questions that they have. The mentors are alumni of the program, so they've already graduated. They're very familiar with the specific projects and things like that. Students can share their screen, work on projects together, ask questions, just work alongside somebody. It's really whatever the student needs, the mentor is there to support.
Gotcha. So our students here, they're expected to reach out to these individuals and then get training with them. Am I going to be involved in that? Are they going to be going over the course curriculum that I'm going to be covering, or do they
No, the
have the
mentors
knowledge on
don't
those subjects?
necessarily instruct anything. They're just there to answer specific questions that the student has, or to help them finish up a project. The student has access to book with the mentors inside their 4geeks.com platform. So they were all trained how to do this during the onboarding sessions. Okay. It has all the mentors there with their availabilities, and they can choose the mentor and choose the time to meet with them and schedule the meeting. These meetings happen outside class time. So the mentor is not going to be teaching anything like new, not going to be, stepping on your toes. They're just there so say the student is working on a project in class, but they don't finish it, and they want a little bit of support to help them finish it up before the next class meets. They can schedule a mentoring session in order to ask those questions and make sure that their work gets done. Okay. Slack is our main channel of communication. If you guys have ever used Discord before, Slack is very similar to Discord. The most important channel for you guys to pay attention to is the Miami CS3. That is the channel that is dedicated specifically to this class. So it's going to be, that's where you guys found the link to join class. So that, all the important getting started information was shared there. But now class announcements, homework, or general class conversation, if your teacher needs to let you know anything, that will all go through that channel. Some other public channels that you may be interested in would be the USA channel. That's going to be like events or campus announcements happening on our USA campus. Public support, cybersecurity. We went over that before, how you can get help if you have that. That's like an alternative to a mentoring session. So if you have a quick one-off question that maybe doesn't need a one-on-one meeting and you just want a kind of a quicker response, instead of posting it in your Miami CS3 and like waiting on your teacher or waiting on one specific classmate to get back to you, if you post it in the public support channel, it's a community of many people who can answer you and help you get your questions answered faster. And then there's various career support channels like jobs, where we post available jobs, hired, where people who have recently gotten hired, we celebrate them, etc. And then a quick checklist of some important points. Number 1, work every day for at least 1 hour. Our founder, Alejandro, he has a podcast. And in the first episode of the podcast, he talks about how the brain learns and retains information. And it's much better for you to do a little bit every day than to try to cram everything into one day and then not study for multiple more days. Your brain will retain much more information by doing a little bit each day. So if you can squeeze in at least 1 hour each day, that's going to be much better for your learning process than, not studying for 3 days in a row, having an 8-hour study session on Saturday, and then not studying for 3 more days in a row. Number 2, don't be afraid to ask questions. Asking questions is something that's very important so that we know that you guys are understanding the material. And in this industry, it's very common to not want to ask questions. This is something that's called imposter syndrome. It's kind of like this unspoken thing where your teacher explains something and nobody asks any questions. So you don't want to ask a question because you don't want to look like you didn't understand because you think everybody else understood. But really, everybody in the class is thinking that exact same thing. So nobody speaks up, even though they don't understand because they don't want to look dumb or look stupid. But really, nobody understood it, yet nobody speaks up. So that is classic imposter syndrome, and it's very common in the tech industry. I experienced this when I took the boot camp. I didn't want to share my screen one time because I thought I was more behind on the project than I was supposed to be. And my teacher was like, share your screen, share your screen. I was like, no, I don't want to. So he ended up calling on somebody else. Somebody else shared their screen, and they were actually like 3 questions behind where I actually was. So you might think that, you're the only one, or this isn't, everybody else is getting it, not you, or things like this. If you do find yourself struggling with imposter syndrome, you can reach out to myself or Laura. We'll be happy to provide you resources or support you through that. But hopefully it doesn't get to you too bad and you guys feel very comfortable asking questions. I kind of combined point 2 and point 4 there. We kind of already talked about point 3, which is the public support cybersecurity chat. The next one is don't spend more than 15 minutes on Google and or ChatGPT looking for a solution. Schedule a mentoring session. So you have the public support channel, you have the one-on-one sessions so you guys can utilize them. And keep your camera on. It improves the mood of the class and the quality of your teacher's performance. It makes your teacher a better teacher, which makes you a better learner and helps the whole educational experience. We want it to be a fun environment, like classic or casual conversation, back and forth, interactive learning. Sometimes students have like a cat that comes on screen and people laugh about it, things like this. We like this calm and friendly energy and not just like a bunch of black squares. And then the last one, attending all classes is crucial. Do not miss more than 2 classes throughout your program. This is adult education. As I said before, we don't, time you. We're not going to kick you out if you're absent more than 2 classes. But this is, again, a recommendation that if you do miss more than 2 classes, especially if those classes are in a row, it's almost impossible to catch up or very difficult to catch up. And we don't want you to fall behind. So everybody gets sick here and there if you miss one class. Or maybe you have a concert one Friday that there's one Friday that you're going to miss class. It's okay. Watch the recording, get the project done, and come back to the next class ready to go. But try your best to keep your absences, maximum 2. Or if it does go to like 3 or so, make sure you're doing your part and watching the recording and catching up on the missing projects. Okay, so that was mine. Is there any questions about what I went over?
That's the same Cody that you presented on, right?
Yes. Cody's your instructor.
Okay, just look different.
So we have Patricia here who will do the career support presentation, and then we'll pass it over to Cody.
Okay, thank you, Elisa. Let me share my screen. Okay, can you see it?
Yeah.
Okay, great. So how many of you want to land a job in tech after graduation? I understand that navigating the market can be a little bit challenging, but we are here to help you every step of the way. I'm Patricia, the Career Support Onboarding Specialist, and I'm here today to explain GigFirst and how it works. So what is GigFirst? GigFirst is a membership focused on guiding each one of you through your career support and placement process. This is the US team. Marcelo is the head of career support, Valentina and Sieta are coordinator, and Valentina, Botana, and Jimenez, and Esperanza, the other advisors. So GigFirst consists of 3 stages. One stage depends on the other, so you need to finish one completely before you can move to the next one, but you will see why. So, stage one, we focus on building your personal brand. This is going to be your resume, your GitHub account, and your LinkedIn. You're going to have some profile review sessions for this, but for stage one, you will have an extra week of classes after finishing the bootcamp just for members. So you will do all of the stage one together. Then, when you move to stage two, in this stage, we are actually getting you ready for job hunt. We're going to explain the importance of networking, having your LinkedIn account active, and also we're going to prepare you for two mock interviews that you're with us. The first one is going to be a behavioral mock interview, and for this interview, we're going to share a document that has like a script with the most common questions they ask. And of course, you will have tips on how you can respond to them. The other one is going to be a technical interview with Alejandro. He will maybe give you feedback or exercises so you can practice. And if you need to do it again, you can do it again. Any of these two, the behavioral or the technical interviews. Then, when you move to stage three, we say is the most independent stage because you will be applying to 5 to 10 jobs per week. And also, you will have follow up meetings, one-on-one meetings with your personal advisor every 2 weeks. And in these meetings, you need to share the content tracker. This is basically a tracker where you have to put what companies you're applying to, which positions, in which parts of the interview you need more help. So, this is going to help us plan a strategy for you and help you with your interviews. So, in the meantime, learning in public offers several benefits, such as building relationships, gaining support, and increasing credibility. It helps friends and family trust your skills, improves your visibility to recruiters, and can lead to faster job placements. To start, you have to set a SMART goal, create a realistic posting schedule, and remember to share your accomplishments on LinkedIn every time you finish a project at forgets.com. And you need to overcome common procrastination thoughts by recognizing that you don't need to be an expert or to have unlimited time. So, yeah, if you need anything, reach me on Slack, and I will see you all in week 12 for onboarding to start the Geek First process.
Thank you, Patricia. Do you guys have any questions about Geek Force?
Yes, when I first was introduced to this program, I was told that there's a guarantee that if you don't land a job in the first 3 or 6 months, that you're reimbursed. Is that true?
So there is a specific enrollment option called Job Guarantee, which it's a higher tuition amount, but then you do get that guarantee that if you follow the Geek Force process and don't get a job within 6 months, you get your money back. So I'm not sure if you enrolled on, we have two enrollment options, which is just called like regular enrollment, which is the regular tuition, or a job
Mhm.
guarantee enrollment, which is more expensive, but you get the job guarantee added benefit. So, and I could check and confirm with you which one you are enrolled in. And I believe that even if you didn't choose job guarantee, if you do want to add it, you have like a window where you are able to add it.
Okay. All right. Thank you.
You're welcome. Any other questions? Okay, great. So Patricia gave a great intro to Geek Force and a great way that you can kind of start Geek Force, even though you're not really starting the career support process full force yet, which is learning in public and posting about the things that you're doing. But right now, your main focus is the technical skills. So the class is going to, start with all the concepts and you're going to be learning the technical part. And then around week 12, as the class still continues, we start incorporating those career support modules into the class. So you start working on your professional profile. But we like to kind of introduce it now so you have an idea about it and know that you have this benefit and it's not a surprise on week 12. So is there any other questions or any other help that you guys need before I pass it over to your instructor about enrollment, about onboarding, about the platforms, about anything? Or you, Cody, if you have any questions too.
I'm good right now.
Okay, great. Well, let me type my name here because I know it says Mentor HQ on my little window, but that is how my name is in Slack. So if you guys need anything, you can feel free to shoot me a message and I'll be happy to help you tonight
Actually,
and forever. Go ahead.
Mentor HQ, do the students have access to the portal that has all the stuff that I'm going to be covering, like the network introduction and all that stuff? Will they be
Yes.
able to Okay.
So you have just the teacher view of the same thing that they have the student view of.
Okay. And then for the answers and stuff, there's quizzes. Do I have like a teacher one that has the answers to the quiz, or am I taking it with them and just kind of guessing along with them?
That's a good question. Let me confirm with Laura and message
Okay.
you.
We can figure it out. Yeah, I was just curious because I didn't see one specifically between teachers and students. So okay.
I'll double check about that.
Cool.
Is the teacher able to see how many times a student has failed a quiz?
I think it just shows your highest score. So what really at 4Geeks, your quiz isn't like, it's not like traditional college where your quiz is the most important. What's the most important is your projects. So we work on a pass fail system here where it's either you did it or you didn't do it. Or it was satisfactory or it was not satisfactory. So if you submit your project, even if your teacher tells you it's not satisfactory, you can go back and fix it, resubmit it, and once your teacher approves it, then you get approved for that module. So as long as you're putting in and doing the work, you will pass this class. There's no like, oh, I failed a quiz and I can't take it again or nothing like that. The readings is for you to learn. The quizzes is for you to reinforce what you read. And then the projects is where you put in that real hands-on and build it. And that is what your, I guess, grade is. We only are really looking at your project completion.
Another question on that. So for the first project for tonight, it says, basically, it's a series of questions to create like a hypothetical scenario. And then it says submit a text document. So are the students expected to like use Google Docs or something or Word document to upload it to the portal, or how does that process work?
I can double check about that too. I personally took the data science course. I didn't take cybersecurity, so I'm not super familiar with the projects, but let me check with Laura, who's the program manager and knows about each individual project, and I'll message you and confirm about that.
Okay. And then the second one too is, am I expected to do these projects as well? Am I expected to upload it because it looks like it's just a standard one? There's no difference.
No, you don't have to do them.
Okay. Okay. That's all I got for now.
Okay. I'll message you in Slack shortly with the answers to those two questions.
Okay.
Okay. Nice to meet you guys. Have fun. Good luck. Talk to you soon. Bye-bye.
Thank you.
All right. Good evening, everyone. Happy New Year's. I'm sorry, Patricia, did you have more stuff to go over?
Oh, no, it's okay.
Okay. Are you going to be hanging out?
No, I'm going to leave.
Okay. All right, cool.
Bye.
Yeah, so Happy New Year's, everyone. Hope everybody had a great holidays with their families and all that stuff. So my name is Cody Mercer, and I'll introduce myself in more detail here in a minute, but it's great to meet you all. Let me share my screen real quick, and we'll go over a couple of things. How's everybody doing tonight? Are y'all happy to be spending your Monday evening learning and doing more work after a long Monday?
You know, Happy New Year.
I'm in San Francisco, so it's only like
Okay.
3:30 in the afternoon, so it's not too late for me.
I'm in Montana, so we're not too far away. Yeah.
I'm in Minnesota.
Okay. How cold is it over there?
Brr.
I'm
Very
in Washington, D.C., and it's cold here with a lot of ice, snow.
Oh yeah, I heard Washington's supposed to get some, DC's supposed to get some crazy weather, I think.
well.
Yeah,
Trust
it's
me,
right here.
I'm in Minnesota. It is super cold here.
Well, we'll see how it affects the playoffs.
Yeah. So can y'all see my screen?
Yes.
Yes.
Okay, cool. So before I jump into this, one thing y'all learn is that I'm super laid back. I'm super chill. So by all means, I've learned over the years to choose your battles and stuff. So I don't take obviously this is very important for y'all. Y'all paid money for this, and it's very important. And the goal here is to make sure that y'all succeed. So my role really here is to make sure that I provide you with all the information and knowledge and all the questions that you have and point you in the right direction. And that's what we're really trying to accomplish here. So feel free to interrupt me. Feel free to ask questions. Like they said earlier, there's no such thing as a bad, stupid question. I'll probably ask dumb questions myself. That's just part of the process. And before I continue, I'll just talk a little bit about myself. So I've been in the cybersecurity industry now since 2002. I've been doing this literally probably every day since then. I started out in the United States Navy, joined the military and did cybersecurity for them. Are there any vets on the line? Anybody in the military? Thank you for your service, sir. What branch?
Army.
What was your MOS?
31 Bravo.
What's that?
Military police.
Oh, nice. Very cool. I did a little police work myself overseas. Nice. So I started doing it for the military. I did cryptography. Maybe we'll talk about a little bit that in the course and what cryptography is. But I did communications and satellite communications as well. From there, I went to work in the government side of the house. So National Security Agency, I was with them for a few years. Department of Defense with them for a few years. Then I went to the private sector where I did nonstop contract work with the government, multiple three-letter agencies. So DOD, NHS, DHS, CISA, DISA, DIA, projects ranging from 2 weeks to 2 years. So I did that for about the first 12 years of my career. And then around 2016, I found myself in San Francisco, Bay Area, where I worked for startups. Where I worked for a handful of startups for about another 5 years, till about 2021-ish, when COVID hit. And then I had to get out of California. And so I found myself in Montana and pretty much just been working remote out of Montana in the snow. So right now it's snowy and cold. So I'm sure Minnesota's got a little bit of snow there as well. So when it comes to cybersecurity, my job in the real world, this is just a part-time gig for fun. I do this for fun to teach. I'm a cybersecurity architect, so I build and design cybersecurity programs for the military, for the government, for the commercial spaces too. And we'll talk about some of these programs that I built out, security stacks, so related to analytics, MDR, EDR, DLP, ZTA, email security, stuff like that. And we'll cover all that stuff. But that's pretty much what I do in my real world job. This is just for fun, to do something on the side. I get to work with great folks like you. During the 23 years of my service and work, I have taught cybersecurity off and on as well. So I taught various certifications like CISSP, CompTIA Network, Sec Plus, Net Plus, ethical hacker as well, to government officials in the military. I've also created course curriculum for certifications as well. So when it comes to experience, I have experience in cybersecurity, and then I also have experience in the instructor side. Now, with that being said, this is the first time that I've worked for this particular company, 4Geeks. This is the first time that I've taught this specific curriculum. I've taught, the subjects we'll go over. I've taught many times before, but as far as their specific stuff, this is the first time I've gone over it. So some of this will be learning for me as well, as far as process and procedures. But again, no worries, you're going to get your money's worth. So like they said, when it comes to these projects and stuff, based off of what I've seen, a lot of it is security related, but a lot of it is also related to theory as well. So understanding the basic fundamentals kind of outside of security that kind of are the underlying foundational work to security. So that'll make more sense here in a little bit. So when it comes to the coursework, it's pretty straightforward. Basically, these classes, what we'll do when we have these Monday, Wednesday, Friday, is I will go over these various different theories, basic underlying information like read, and then we'll get into the project. And then we'll also get into some quizzes. Again, this is my first time going this process and flow, so it probably won't be as smooth as we'd like the first couple of times, but we'll get it down and you will succeed. No questions there. So any questions before I continue? Everybody good so far?
I'm good.
Cool.
Sure, I'm
so
good.
that's kind of the coursework. That's the overflow. I'll basically be going over those topics related to theory, and then we'll go into the actual, like the project, and then we'll go into the quizzes as well. So again, as they said, ask lots of questions. Please interrupt me. I found when teaching these courses, the more involved people are, the more questions they ask, the more people, are voicing their frustrations or whatever, the more you're going to gain, the more you're going to retain, the more you're going to get it. I already know this information. So this is really for you guys. And yes, is it okay if I call you, how do you pronounce your first name? I'm really bad with names, so I don't want to butcher anybody's names right off the bat. So is it okay if I call you Pitts? Is that okay? Okay, cool. Yes,
All
Pitts.
right. Are these all the students?
It looks like it. I was told that originally there was 4, and then they postponed it, and now there's only 3. So yeah, I guess which is kind of good because you're going to get more out of it. It's more, one-on-one, closer stuff.
Less
So
served, the better.
I think it'll be a little bit better that way. So yeah.
Yeah, it seems very one-sided ethnically.
And what do you mean?
We're all black.
Oh yeah, except for me. Yeah.
I didn't
That's
even
all right.
notice.
The information is not
Honestly.
going to. The information will
Yeah,
be the same.
I'm just here to learn. I'm like, I honestly didn't even notice. But
Yeah, I didn't notice either. So I don't really focus on that stuff, but.
me either.
So yeah, and then we'll do regular breaks too. So studies show that the average person can only go about 45 minutes straight of continuous focus before they start to drift off and before they start to lose their focus. So we'll try to rotate, like on the hour we'll take 10-minute breaks or whatever, but if y'all want more, if y'all need a bathroom break or whatever, by all means, this is y'all's course. So you let me know. I work for you guys. You tell me what you want. But that'll be the goal for now. It's just kind of on the hour, every 45, 50 minutes. We'll take, a 10-minute break and do whatever.
Okay.
And then finally, continuous improvement too. So, again, my goal is to have you succeed. And so, if you have feedback, if you have suggestions to make this course better, if there's something that you want more information on, by all means, this is for y'all. So the only way to really make things better and improve on things is by people voicing their, opinions, and then we can make improvements moving forward. So by all means, to make this course better and for you to succeed, provide your feedback and we can make things happen. So real world application again. I've been in the real world, hands-on, doing cybersecurity for the military and the government and startups for 2 decades now. So if you have questions related to, when it comes to those, they mentioned interviews and getting jobs in the real world. If you have any questions regarding that, anything at all, I may be a good source for that too. So just to throw that out there. So with that being said, I introduced myself. What I would like from you guys, is however comfortable as y'all feel, but 2 things I'd really like to know from you is, one, what's your level of cybersecurity knowledge? How much do you know about it? Just so I know how detailed or how non-detailed I can be. And then what is your goal with the course? Are you looks like some of y'all raise your hands for, getting a job in security. So that's a great, security industry is a great place to be. It's always, needing people. It's always undermanned. So if that's the case, great. So those are the 2 things I'd really like to know. And then additionally too, what state or country you're calling from, so I know what time zone you're in. Other than that, anything else you want to share, you feel comfortable sharing with, by all means, please do it. So whoever wants to go first.
I'll go first since I'm unmuted. I'm unmuted. I'm Teresa, and I'm originally from Jamaica. I moved from Jamaica to Minnesota, and I really like it here. It's very nice. The weather is different, but I'm not a person that likes the heat, so Minnesota works well for me. Just like the other party said, I got into cybersecurity, but I was introduced to cybersecurity last year. And with the coding part, I kind of like numbers and I kind of like difficult things a little bit. It works easier for me. I'm kind of backwards. So I found that it worked for me. And I'm like, you know what? Let me try this. And as I started doing some courses, I I started to love it. So I said, you know what? Let me go into. I wanted to make cybersecurity my career, so only career until I leave this earth. So here I am. Yeah.
What are you doing right now in your professional?
I actually was in childcare for a long time. I have my own business. I had my own business for 13 years. I did childcare, but I was tired. So I'm like, let me just move on to, something that I love. It's my second love. Other than childcare, I never liked anything else. So this is something that I'm in love with. So I want it to be a career forever. Yeah.
Nice. Thank you.
Mhm.
Okay. Can you hear me?
Yep.
I can hear you.
Okay. My name is Abu Mary, and you can just call me Abu, ABU. I'm originally from Nigeria. I moved here to Washington, D.C. some few years ago, and I'm actually looking for a career switch. My background is accounting. I read accounting back home, and coming here, I have been working with a mental health agency as a community support worker. Then I'm looking to switch my career from being in the health industry to IT industry. So in the course of doing this, I've taken a few courses in Oracle database administration and DevOps and AWS. So now I'm doing a cybersecurity, hoping to put the whole team together to have a career switch in IT.
All right. Thank you, Abu.
My name is Ukoma Pitts, but everybody calls me Yuki. My background in cybersecurity is none. I am completely fresh to it. Reason why I choose cybersecurity is because I want to rob banks and get paid for it.
This is being recorded, so just a heads up, Pitts.
Yeah, I know.
Cool.
Something about myself. I am a professional magician in San Francisco.
Really?
Yes,
Seriously? That's awesome. So you know who Chris Angel is?
Yes.
Yeah, he was my hero for a long time. Not anymore, but he was when he had his show. Mind Freak. That's one of my favorite shows. That's awesome.
Yeah, I have a project that I'm working on. I'm having a web designer build it for me, and I want to be the one that protects the website because it's going to be designed for international use.
You broke up there. It's gonna be designed for what?
International use.
International use. Gotcha. Well, that's cool because halfway through this course, we're going to be setting up a WordPress site and then we're going to be attacking it. So that's ideal for you. So that'll be cool. Do you like street magic or anything? What's your specialty? Do you like, is there anything that you prefer doing?
I've been doing a lot of stage the past year or so. I've been practicing for 15 years. I've been performing for 4 years. This is my 4th year. And actually have an audition for America's Got Talent this Sunday coming up.
Nice. Well, good luck with that. Maybe one day, if you're feeling comfortable, you can do a trick for us. I would love to see that. I love magic. Seriously, that's awesome. Abu, I'm not sure. What state did you say you're in? I'm sorry, sir. I didn't hear you. I wasn't paying attention. You're muted.
Washington, D.C.
Oh, DC. I'm sorry. Yeah.
Yeah,
Sorry about
DC,
that.
yeah.
Cool. Yeah. All right. Perfect. Well, thank you for all of that stuff. So, you guys just want to jump right into this and start knocking it out? You guys want to take a little break? Are you good? I'm good either way. This is up to y'all. So we can keep trucking if you want. All right.
I'm ready to start. And dive right in.
Been waiting
So,
for
do y'all have a screen similar to what I'm looking at right now?
Yes.
Y'all have that same thing? Okay, cool.
Yeah.
So just a heads up, guys. No fault of the people who hired me, but I didn't get a whole lot of like training or walkthrough. They basically just said, "Here's the stuff. Here's teach it and move on forward." So if I ask some silly questions, I apologize in advance. It's just because I don't know. Okay. So everybody has access to this, and y'all have these answer question things, everything like that, pretty much the same. Y'all are seeing the same thing?
Mm-hmm.
Okay, cool. It might be identical. There might actually not be a difference between any of them, but okay. Well, without further ado, so some of this stuff again, if it were up to me and if I had the choice, I would skip a lot of some of this, basic underlying theory stuff and just go straight into cybersecurity. But I'm not the one who's designing the course. I actually made a recommendation. They only gave me a little bit of time. So they only give me 9 hours a week to do this. Same with you guys. So it's not like I can devote a whole bunch of free time on my own and not get paid for it. So, I haven't gone through every single word for word on all of these, but the ones that I have seen, it's good to know. But when it comes to cybersecurity, it's kind of like your math courses in, high school or something when you're learning algebra and stuff. Like, it's good to know, but in the real world, how much of it are you actually going to use? Probably not a whole lot. But I just say that because, again, when it comes to critiquing and it comes to your feedback, I've already provided my feedback. I mentioned that, a lot of this stuff should be more geared towards cybersecurity and less on theory. And I've offered to provide services to help build their curriculum for them. But, if some of this stuff you feel you're not getting your money's worth, again, this is y'all's money. And so y'all get what you put into it. So, if you feel inclined to, provide your feedback and say, we would like more information, more on cybersecurity and less on networking, then, I'd recommend it because that's how things change, right? And that's how things get better. So just to throw that out there. So I'm not one to read, line for line any of this stuff, but what I would recommend, it's not a whole lot of reading, but I will go over this stuff and highlight the main points. But I would also recommend, again, that you spend the time reading this on your own as well. This probably could be read in 10 15 minutes or something, but just so you have it for your own personal knowledge and stuff. So our first topic is going to be related to networking. So I know you mentioned Abu, who did the Oracle certification, who has experience in basic IT stuff. Was it you, Abu? Who's taking Oracle certification stuff? You're on mute, buddy.
You're muted.
Yeah. Okay.
Abu,
That was it. Aside from Abu, Pitts, or Teresa, do y'all have any experience in IT stuff? Any computer related experience? When I say networking, does anything come to mind? It's okay to say no. I'm just curious on how detailed
I
need
did
to be.
like a course on Coursera in the one on Udemy.
Uh-huh.
Yeah.
I taught myself how to do C++ and JavaScript.
Oh wow. Okay. So you're advanced then. So that's way beyond this. So that's cool. So again, I'll cover this stuff, but a lot of it's not directly related to cybersecurity, but it's good to know. So Just basic networking introduction. So networks revolutionize the way the world communicates and information. So think of networking, that's your backbone. So networking, that's kind of that's your base, that's your foundation, that's how everything works. So me and you are talking to each other. I'm talking to Pitts and to Teresa and to Abu. While I'm talking, and then the words get to Teresa on her side, it goes through this massive networking process, right? And it goes through thousands and thousands of different IP hops, and it gets really complicated, and it all happens in milliseconds, and it's pretty fascinating. So think of network, that's your backbone. That's how everything works. That's where it all starts. And so the history of networking, ARPANET right here, Advanced Research Project Agency Network, and developed this in the 1960s. And the goal really here is to have standardization across the board. You can't have this group over here creating some type of standardization, and then another group over here creating another standardization. You need to have one singular standardization so everything can coordinate and work and integrate and work together, if that makes sense. So apparently ARPANET, this was created in Berkeley in 1969. A lot of stuff happens in Berkeley. As you know, Pitts, you're from that area, so you know that's where a lot of cybersecurity and computer science and a lot of stuff that we use today kind of originated from. They're kind of at the epicenter, and they're doing a lot of cool things related to computers, and will always be doing that. But anyways, ARPANET, they created, kind of the first standardization of how all of these computers and how the internet and everything can really work together. So what's really important is something called TCP/IP, Transmission Control and Internet Protocol. This was a crucial step in connecting different networks to interconnected systems, and this is essentially that's your foundational work. And then, are you good, Teresa? Do you need a break? Are you all right?
Oh no, I'm good. I just looked up. I didn't see myself. I'm like, where am I?
All right, cool. Everybody.
No, real
quick.
You said started in Berkeley. It says in the second line it was in UCLA.
Oh, okay. Yeah, that's probably right. Where did I get Berkeley from? I saw Berkeley in here somewhere. Oh well. So yeah, University of California, Stanford Research, Santa Barbara. Maybe I was getting Berkeley and Barbara confused. But this is the origination of it all. And so if that's something y'all are interested in, read through this for more. But basically what came out of it is standardization across the board. So your communication protocols. Protocols are a set of rules and standards that define how devices on a network should communicate with each other. So we'll get into more depth, but again, a lot of this stuff is related to network, and I don't want to go too much down a rabbit hole on this stuff because it's going to detract you from the main stuff of why we're here related to cybersecurity. And taking in too much information, might throw you off from other stuff. So I don't want to confuse you guys too much. And if I do, then interrupt me and we can go into more depth. But there's, I think, 60,000 protocols, ports and protocols, all do different things. And we'll go into detail on some of them more. But one of them is HTTP, Hypertext Transfer Protocols. Anybody know what port number that is? We'll look that up. That's a guess, a question for later.
I think that's 22.
HTTP 443.
Sorry, 443. 443.
Yeah.
Yeah, 22 is.
And then, let's see. Yeah, go ahead. You can interrupt. You don't have to put your hand up. Just cut me off.
So my computer is gonna die any second. I can hear you, but I'm gonna go look for my charger while the class continues.
Okay.
All right, thank you.
Yep. So data packetization, information is divided into smaller packets. So that's how information is communicated through packets. And again, not to go into too much detail, but each packet has a header, and then it has date, time, and then it has your body, and then it has your information. And that's how information is transcribed from one point to another, is through packets. And the way that's done is through routing and switching. And we'll go into more details on this here in a little bit. But routing and switching, just as it sounds, is you're able to route data to different areas based off of routing tables and things like that. The client server model, that's the standard in many networks. That's the basic. An example would be Amazon is the server. I'm the client user. I am connected to the Amazon server to provide some type of function. That's kind of the model that they're referring to. So servers often store resources, web pages, files, services, things like that. And then clients like us, the users, are going to request various services, capabilities of those web pages of that particular server. And servers can provide a whole list of different things. And we'll go into more detail as far as what they can offer. So a network occurs when one device manages to connect to another and exchange information with it. This is not something that happens magically, as there are several conditions for the communication to be possible. Before knowing those conditions, let's get to know the types of networks. So you have LAN, local area network. This is your more standard, typical configuration. They cover limited geographical areas, usually offices, buildings, houses, cities, and so forth. And then you have your WAN, your wide area networks, and those cover larger areas, country to country, things like that. MAN, metropolitan area, you don't hear that too much, but they're designed to cover metropolitan areas as well as the city, same as the LAN, but more coverage than your LAN. Wireless networks, probably all of us are using wireless networks right now. So you set up a router, and then you don't have direct like cable connections, but rather it's all in the air via wireless. And we'll go into more detail on those. SANs, your storage area networks, often these are devices, servers that do just that. They do nothing but just hold data and storage devices. And then peer-to-peer networks. Peer-to-peer is like, what is it, Napster and stuff like that, where you can do point-to-point. And that's basically, like a central server, client-to-client type file sharing application, stuff like that. Are y'all familiar with Napster? Am I dating myself? Are y'all familiar with Napster at all? Abu, you familiar with Napster? The file transfer sharing? So these are the different topologies, network topologies. All of these are going to be irrelevant, and I'll cover them here in detail. The main one you want to focus on that's of any value is this one right here. Why? Because there's something called HADR, high availability and disaster recovery. Anytime you're setting up any type of infrastructure, any type of computer, any type of servers that have any big value, you want to ensure you have disaster recovery and high availability. And based off of this topology, the mesh topology, that's going to offer it. You're not going to be able to get it with something like this, a ring topology. Why? Because if there's a single connection break here, you're not going to get any communication to any of the other ones. Same thing with there. If there's a communication break in any one of those, none of these computers can communicate with each other. So this is a bus. This is a star, same thing. And it breaks it down here, disadvantage. If the central point fails, the entire network is affected. Same thing with this one, disadvantage. If the main cable breaks or fails, the entire network may stop working. So in the real world application, very rarely will you see anything other than a mesh topology mainly for that reason alone. You might see like a ring or a star, but it's going to be for a very specific reason. Maybe it's for testing or something like that, but it doesn't happen very often. And then we have the tree topology as well. So again, disadvantage, if the root node fails, it can affect the entire network as well. And the way I remember these is just like it looks like. So, this one can kind of look like a tree. This one obviously looks like a ring. This one looks like, straight bus point to point. This looks like a star. So that's the main way to kind of understand these. Any questions on this? It's pretty straightforward. Yep. So these are different types of servers. So we talked about the client to server configuration type. So servers will provide many different capabilities. You can make it do whatever you want. And the ports and protocols associated with those particular servers will dictate what that server is going to do. For example, web server, that's going to be port 443, HTTP, and HTTPS. That's going to host web server, web applications, images, stuff like that associated with the web. Email server as well. Abu, would you mind muting your mic? I think we got some feedback on your side.
Yeah.
No worries. Appreciate it. Database. Just as it sounds, so manages the storage of data. Application server, host applications, proxy server, acts as an intermediary between devices on local networks and resources on the internet, can improve its security. So the way a proxy server works is anytime you would have, say, a company that wants to allow people to access resources within their network, they're not going to give the direct IP address to, say, their email or database server. They're going to give a proxy server, and that's going to be an intermittent IP address that's going to act as an obfuscation, so you don't have access to that direct specific IP address. You have a proxy IP address. And again, this is for security purposes. Domain name service. So this is translate human readable domains to IP addresses. So when you go to type in something up here, we're not typing in the specific IP address. We're typing in words, right? And so what happens is once we type in the words in this URL, it goes to a domain name service server that hosts the IP addresses, the actual numbers associated with this particular URL. And it basically transcribes it from human readable form to numeric number. Does that make sense?
Yes.
And then finally, virtual private network. So this is for security purposes as well, but it allows you pretty much to go from point to point to where you don't have to go through the corporate cloud, the corporate resources, and expose various potentially vulnerable servers or vulnerable IPs that could be exploited. You're going in a virtual private network that creates a lot more security, and that's usually the de facto way of doing things if you have to communicate on a large scale. It adds another layer of security. So, role of servers in an enterprise computer network. In an enterprise computer network, servers play a crucial role in managing shared resources and servers. So, centralization of resources allows resources and files to be in a centralized location, and so it's not spread out. This allows, again, greater security, greater management, everything associated with that. User management, servers can implement security and authentication protocols for user access. Backup and storage. So this is associated with high availability as well. So always having your backups in case something happens. Internal, external communications. So your emails and stuff like that. Your web servers. So web publishing and application management as well. So that is that one. We'll mark that. Do y'all have on your thing when we go through this, do y'all have a place where you can mark completed as well? Do y'all have that same thing? Okay, cool.
Yes.
All right, I'll run through this one because it's a little short, and then we'll take like a 10-minute break. So the next one, when we're talking about standardization across the board, there's another standardization known as OSI, Open Systems Interconnection Model, and the TCP/IP Control Internet Protocol model as well. So the way I remember this, and people come up with their own acronyms, but all people seem to need data plans. So all people seem to need data plans. And that's my own personal way of memorizing this and remembering it. Y'all can come up with your own acronym. But basically what this is it's the standardization, and it's the process from which I am on my computer, and let's say I type in something to access something on Amazon, or I want to buy something on Amazon. This is the full process from start to finish. Everything that occurs from me typing on that keyboard, which would be the physical, going to the data link, which is going to the actual cables that are sending the information via electricity or whatever the case may be, to the network that we just talked about, where you have your routing and your switching and everything like that, to your transport layer, which is your TCP IP protocols, to the session that's created, to the presentation. Right now we're looking at presentation and application. So as I've moved my mouse and everything, we're at the layer, the presentation layer, and the application that we're looking at, like Google is the web application itself. So it's essentially, it breaks down specifically, every single thing that takes place from point A all the way to the end. So I know that's a lot to digest, but does that kind of make sense?
Yeah. Yes, sir.
Pitts, are you back? Are you still away?
I'm here, but my
Okay,
camera's down.
No worries. I just want to make sure you're still there. Okay, cool. So, yeah, I'm sure there's going to be questions related to quiz on this. Anytime you take any type of security certification or CompTIA certification, this is one of the questions that always is going to come up, is what is the OSI model? And let's say one question would be like, if a user is on their browser and they click on a tab in their Google web browser, what layer are they at? And we'd be at the application layer, right? What we just covered. Another one would be is, where does TCP IP occur within the OSI model? That would be at your session and transport layers 4 and 5. Like, where are your routing, switching, and firewalls? What layer does that occur at? And that's at your network layer. So again, application layer, this is the layer where applications and end users interact. It provides network services to applications, file transfer, email, web browsing. The presentation layer, this is responsible for the presentation of that data and encryption. It converts data to a format that can be understood. So when it talks about encryption, when you send data over the internet, you're not just sending it in what's known as plain text, because it can be intercepted, and then it could be, as Pitt said, to rob a bank. You'd be able to take someone's personal information, their credit card number, their password, their user information, and they can use it how they want. So in order to avoid that from happening, you have to encrypt that type of data. And that's where, through the OSI layer process, data gets encrypted when it gets from point A to point B. And that's just a part of the process. It's known as TLS, Transport Security Layer, TSL, Transport Security Layer, or TLS, one of those. But basically, that's the encryption process from point A to point B. Your session layer maintains and terminates the session connections between two devices. Example, initiating an online chat session. Your transport layer handles end-to-end user data transfer and ensures that the data is delivered reliably. Example, TCP IP control. Your network layer. So the network layer is responsible for the direction of routing of data through the network. Example, Internet Protocol assigns IP addresses to devices and routes data packets across the Internet. Your data link layer, this handles communication between devices on the same local and is responsible for error detection and correction. An example, Ethernet standard that controls communication in a wired network. And finally, your physical layer. First is the physical transmission and reception of data, such as the cables, which we just spoke about, electromagnetic waves, mechanical and functional specifications of the network devices. So examples, Ethernet cable, electrical signals, coaxial, radio signals, wireless network. So in summary, the OSI model divides the communication process into 7 layers, each with specific functions. As data is transmitted from the application layer to the physical layer and then received at the destination device, each layer has its own set of functions and headers to enable communication between the network. The structure itself makes it easier to understand and troubleshoots computer networks. So I know that's a lot of information we just covered. I don't expect you to be a genius on this, but for the most part, does that kind of make sense? You're not all going to get it right off the bat, but does that kind of flow? Does that kind of make sense at all? Abu, Pitts, are y'all good? Does that make sense?
I was kind of scattering around a little bit, so I didn't catch all of it. But I'm going to read it all after class. So
yeah, read it all and then take notes, take questions, and then we'll cover those questions too, because I'm sure you'll have some. So in summary, the OSI model divides the communication process. Oh, I just went over that. Okay. So each layer communicates with adjacent layers through well-defined interfaces. The OSI model is a widely accepted theoretical reference to help understand how network protocols work and how they organize into a protocol stack. So transmission control protocol, internet protocol is a practical reference model that is based on the design of the internet and is used to describe how devices communicate with the internet. So this is more just the TCP IP model that's more focused just on the internet process. The OSI model that encompasses everything, but just within the internet process, the main functions are going to be your application, transport, internet, and network. The TCP model is widely used in network configuration and administration and conforms more directly to the internet architecture and is a simpler implement and understand. So this goes into more detail. So the network layer, responsible for transmission of data on the physical network. Example, Ethernet and Wi-Fi are common network access layer protocols. So when you think about like wireless routers and stuff like that, that would be the network layer. Internet layer, responsible for routing the data between IP addresses. So an example, when you enter a URL in your browser, so like right here, if I enter some URL in my browser, like this, example.com, the internet layer resolves that IP address associated with that domain name and routes that request through the global network. So which type of server I just covered addresses this part that takes an IP address and resolves it with the domain name. I just went over it. See if y'all are asleep yet.
Internet.
Do you know? So that's going to be your DNS server, domain name server. That's going to translate that IP address. That's going to be this one right here. Domain name server translates human readable domain names into IP addresses. Does that make sense?
yes.
Okay. So if that gets annoying with me asking if that makes sense, I just want to make sure that I'm not losing you guys. So that's where that occurs right there. It resolves IP addresses to the domain name. Transport layer. So again, this involves the TCP transport layer protocol used for reliable data transfer. And then finally, the application layer, which we're looking at right now. We're on the application layer as I speak. Example, hypertext HTTP. That's what this is right here. Used to access web pages. When you browse a website, your browser uses HTTP request and receiving pages. Bonus question. Does anybody know what HTTPS stands for as opposed to
I
just
was just about to
HTTP?
ask you the difference.
Good question. So S just means secure. So they both do the same thing, but one is more secure and uses encryption versus one that's unsecure. So anytime you're doing any type of transactions, personal information, any type of if you're buying something online, if you're giving your credit card information, if you're doing anything regarding PII, personal information, uh, if you don't have HTTPS and it's not secure, that means it's vulnerable. Get away from it. You don't want to have anything to do with it. You always want to make sure HTTPS. And usually that's a standard. Very rarely do you find anything that's just straight up HTTP now. There's always going to be usually an S associated with it because it just kind of has to be. So it's important to note that TCP IP model's practical model adapts to the internet architecture and focuses on functionality of the different layers without strictly dividing it into 7 layers like the OSI model. These 4 layers are sufficient to understand how internet networks work and how devices and applications communicate. Each layer plays an important role in transferring data across the overall network. And finally, the importance of these models lies in the fact that they provide a common language and organizational structure for network communication. So that's really it. Out of everything I just spoke about, the main thing, yes, it's important to know specifically what each layers do and what purpose they serve, but more importantly, why are they there? It's because you need to have a formal organized structure that's compliant across all different countries, all different languages, all different technologies. So you have one standardization across the board. That's the biggest takeaway. They help network engineers and IT professionals better understand how protocols and devices interact in a network, troubleshoot network problems, and design efficient and secure networks. That was a lot there. Who has questions? Are y'all good? So good so
I'm
far.
good.
Okay, so we've been going an hour and 15 minutes. I will set my timer. How's like 7-8 minutes sound? Are y'all good with that? Just come back in like 5-10 minutes. Are y'all good?
So at 4:21.
Sure.
It's
That's
5
good with
minutes.
y'all. Okay. All right, I'm gonna get some water.
Anybody want to see a trick?
Yeah, let's see it.
All right, so I have a holy card because it's holy. Now watch very closely as I take the hole right off the card and put it right back.
Yeah.
Yeah, I'll do it again. Right off the card and back. Well, wait. There's more. Off the card and back. Now they come together like magnets. So these three come close while the last one repels. And you have a holy card.
Okay.
You're the real deal. You are the real deal.
Thank you. I better be after 15 years.
I've been wanting to get like one of those little magic kits that you get for kids just to do it for fun. But my hands are too big. I don't think I can hide too much stuff. Or maybe I can hide better things because my hands are bigger, right?
Yeah, if you have big hands, I will recommend to stick to classic stuff like cups and balls and card magic. Because if you have big hands, you can switch a deck if you can palm an entire deck.
Yeah. Yeah. All right, cool. Well, let's jump back into this.
Oh, I do have a question. So, to be a penetration tester,
Yeah.
what's the difference between a penetration tester and a bank robber?
Gosh. One you probably want a gun. The other one you only need a computer. All you need is a Wi-Fi connection. Should be good.
All right.
Okay. Is everybody ready to go?
Yeah.
Yes, I am.
All right, cool. So again, I know this stuff is a little me. I love cybersecurity. Again, I've been doing it literally every day of my life since 2002. It's something I enjoy very much. I know this stuff is a little kind of boring, but I think it's important because you do have to understand kind of the basic fundamentals of how it all plays together. But just stick with us, and I think it'll get more fun here as we start getting into more of the security stuff. So here we have some different elements of enterprise network architecture. It's not, they call it enterprise architecture, but this is network architecture in general. All of these concepts apply regardless if it's enterprise or not. So when I say enterprise, what do you think I mean by that? Does anything come to mind? So just think of enterprise is really big, like really big. So normally in the fields, in the industry, it's broken down into three classifications. You have SMB, which stands for small managed business, and that's usually companies with headcounts. Those are like your startups. Those are like anywhere from 0 or 1 to 100 people at most. That's SMB. That's small managed business. Next is your mid market. That's usually between 100 to 700. And again, every company's threshold and headcount is a little different. And then enterprise is usually 1,000 headcount or more. So that's how they classify different sizes of infrastructure, different sizes of companies. They'll say, are you SMB? Are you mid-market? Are you enterprise? Why that's important is because a lot of cybersecurity and just IT companies in general, they'll only market and they'll only sell to a certain size. They'll only do enterprise or they'll only do mid-market for whatever reason. So that's how they just distinguish it. And that's just, just terminology in the biz. So when they say enterprise, they're talking about large, big scale, bigger than average, like your companies like Amazon or MasterCard or, think of really big companies like that. So these are just some standard terminology. So network architecture can vary significantly in size and complexity, from small home networks to large enterprise and telecommunication networks. Here are some key elements. And I won't read these word for word, but I would suggest, advise, call it what you want, but to go over these, and make sure you understand them. It's not super complicated, but it's important to know. So network components, stuff we just talked about. So that can really be anything. In this case, it's going to be your firewalls, your servers, your workstations, your switches, your routers. So I wish that they had better diagrams, but when I talk about routing and switching, let me go back to my different topologies. And so this basic one right here, this could either act as either a router or a switch. But let me Google real quick and see. Let me find a better picture for you guys real quick. Let's see. Okay, so when you look at this is usually when you have something circular like this is your standard icon for a router. So normally you would have something like and this is your standard switch, router. And usually the way it works is you'll have like on the outside of a bank, you will have a firewall, and then it'll hit either your router or your switching. And so those are just your basic
We did that in our pre-work.
Okay, cool. So network components, again, your firewalls, your switches, your routers, your hubs, your workstations, your mobile devices, basically any type of IT device or anything that can connect to an internet, a computer. Those are your standard network components. And then your protocols. Again, I think there's around 60,000 protocols. I think the first 50,000 or whatever, I would say 50,000 out of those 60 are private, meaning they don't hold a lot of weight, but you have your common ones. So like DHCP, Dynamic Host Control Protocol, DNS, we covered. FTP is File Transfer Protocol, HTTP, TCP. I won't go into detail with this because, again, I don't want to overload you with information that's not going to be super relevant, but I think it would be helpful for you just to understand some of your basic protocols like FTP, DNS, and I'm sure we'll go over some of those, as we go down the line. But network segmentation. So networks are often divided into segments to improve management and security. This can include subnets to isolate traffic. So just as it sounds, the reason why you want to segment different network components, again, is for security. So let's say you have a company that has an HR department, has operations department, an IT department, a security department. Well, when you create a subnet and you create different subnets for different departments. You wouldn't want to group your operations with your HR, or you wouldn't want to group more than two departments together, because if you compromise one, that means you compromise the other. So that's why you introduce network segmentation. So you break it up into little groups. So that way, if you do get compromised, you don't get the keys to the kingdom and you don't corrupt the whole network. You're only corrupting that one little subnet. So network segmentation plays a big role when it comes to security within the space. Network security, critical components, any network architecture. Again, that involves implementing firewalls, IDS, intrusion detection, and IPS, intrusion prevention. They are all the exact same thing. They're firewalls that prevent various ports from allowing communication to occur. User authentication, which we'll go into more detail. IPAM, which is known as Identity Privilege Access Management. Data encryption, which we talked about a little bit, like TLS, stuff like that. Protect network against threats and cyber attacks. So scalability and performance. As you know, anytime you buy a computer, it's usually only good for a year or two before new technology comes out and you need to get something new. So the ability to scale is really important, especially when you're talking about bare metal data center. So most operations occur within the cloud. So like Amazon, AWS, Azure, stuff like that, you're going to build in the cloud because it's very easy to scale. However, when you build on-prem, when we're talking about actually buying physical devices like physical firewalls, physical routers, which is known as archaic, kind of old school technology, because now it's all done in the cloud. You have like virtual firewalls, virtual routers in Azure and AWS. And the reason why you do that is for a lot of reasons, but one is cost and scalability. When it comes to having to scale up, and say add in a new subnets or add additional firewalls, you can do that in Amazon or Azure, AWS, in a matter of minutes. If you have bare metal to where it's a physical device, like an actual physical center that you drive to and you physically connect stuff together, when you have to scale that out, it becomes much more expensive, much more timely. There's a lot more involved. You have to actually buy physical devices and connect them together, whereas opposed to doing it in the cloud, it's just point and click in a matter of seconds. So scalability and performance play a big role when it comes to designing the security and IT infrastructure as a whole, because you have to think about 2 years down the line, when your current technology is no longer adequate and you need to scale up, well, then you're going to have to grow and you're going to have to increase, which means you're going to have to spend money to build out more, right? And so these are concepts that need to be taken into consideration when you're designing these infrastructures. When it comes to yours, how do we want to do it? Do we want to do this in the cloud to where it's going to be much cheaper and easier to maintain, or do we want to do this bare metal? The thing about doing a bare metal on-prem is usually government and military require it. A lot of government and military do not allow for cloud related type infrastructure because it poses too many security risks. And of course, the government military, they're 20 years behind the loop. So oftentimes, the only people who really build out bare metal physical locations now is usually the military or government, because they have to, because of compliance regulations, as opposed to a commercial startup or something. They're going to do it in the cloud because it's much cheaper, it's much faster, it's easier to maintain, so on and so forth. Next is redundancy. So redundancy involves duplication of critical components in the network to ensure continuous availability. So again, I keep harping on the high availability disaster recovery, HADR. That's a term you're going to hear quite a bit when it comes to security, because it's very critical and it's very important. It's one of the most important aspects of security, having that redundancy, right? Think of it as...
I wanted to ask, you talked about the only people doing the bare metal thing, they are the military, government agencies.
Not all. Yeah. I'm sorry, not all, but usually that's what we see in the industry. Yeah, it's not the standard. There are other commercials that do it, but you don't see it as often these days. Yeah.
I was going to ask about private cloud. Are they not considering things like that? Because instead of being in the commercial section, they can just have their own private cloud built out for them, explicitly for them, exclusively for them, and they don't share.
Private cloud's great. It can be very expensive though. That's the only thing, is that once it's expensive to build it out, but once you have it, the initial upfront costs are going to be more, but when you're thinking later on down the line, when you're talking about scalability and everything, it actually saves you a lot of money. So it's the better way to go. Yeah, if you can have your own private cloud, that's great. But again, it's very expensive. Your startup costs are a lot more. But that does happen. Yeah, if you can afford it, that's great. Network management, just how it sounds, involves network monitoring and configuration, maintenance, and troubleshooting. So that involves everything associated with day-to-day basic operations, setting up servers, making sure that you're monitoring the traffic, making sure that everything looks good. There hasn't been any breaches or anything like that, and we'll get more into detail with that later on. Policies and procedures. So this is critical. This is kind of your backbone to everything. So security policies and procedures, acceptable use policies, an integral part of network architecture, establishes the rules and regulations. So policies and procedures are everything. That's kind of anytime you go to build out anything related to security or IT, your policies and procedures are kind of like your de facto backbone baseline to everything that takes place. Let's see. Network architecture is a structured framework that defines how a computer network will be designed, implemented, and managed. It is tailored to the specific needs of the organization and takes into account topology, components, protocols, security, and other essential aspects to secure network operation. So no network architecture will be the same twice. Every situation is always going to be different. Every environment's going to be different depending on the company and what the company does as far as their business model is, what industry they operate in, government or military. That's all going to dictate, what your architecture is going to look like. It's always going to be a little bit different. You may have a base to start off with and how it's been done before over here, but very rarely can you just replicate one thing to the next and copy exactly how it is, because there's just too many factors involved that are going to dictate how the overall end product is going to be. So let's move to an enterprise context. Designing and implementing a network architecture is an enterprise. In an enterprise is a process that requires careful planning and consideration of multiple factors. Here's a summary of typical steps involved. So requirements and objectives. So as I just kind of mentioned just now, first thing is to identify specific requirements and objectives of the networks. What does the network need to satisfy? This is a term also known as your use cases and your success criteria. Anytime you go to build something out, first thing you want to determine is, what is the use case? What is it you're trying to accomplish? What is the goal? What do we want to accomplish by building out this network? That's known as a use case. And then your success criteria are, what are we going to achieve? We want to achieve this. We want to make sure that we can do this. So when you're building out these networks and you're doing testing in a non-production environment, you test for your use cases and your success criteria to make sure that you're meeting your objectives. Network topology. So again, deciding on the network topology is a critical step. Common topologies include star, bus, ring, and mesh. Now, again, mesh is going to be the primary one that I've always seen. I've never really seen a star, bus, ring. I can't really think of it unless it's in a very odd situation. But in real world, you're not going to have it because, again, it doesn't offer the HADR that you need. So usually it's going to be a nest topology. The choice depends on the requirements and the desired scalability. So again, going back to the components, as we mentioned a couple times, firewall, servers, workstations, IP addressing and subnetting. So planning the allocation of IP addresses and creation of subnets is essential. Have y'all heard of routing tables before? Have y'all heard of routers? Y'all know what routers are, right? I kind of spoke to it a little bit.
Yes.
So within a router, you're going to have routing tables, and your routing tables define those subnets that we talked about and I don't want to get too much into the weeds on it because it really detracts from the security aspect of it. But in short, but in short, with your routers, you're going to have your subnets and your IP tables, and that's how you break it all down. They have IP table calculators that are used. The military, when I was training with them years and years and years ago, they made us do it, on paper and pencil, and it's a real pain in the butt. Even for people who are okay with numbers, it's still really painful. And my recommendation is to use a calculator regardless, because even if you are good with numbers, it's very easy to mess that stuff up. And once it's off, it can go really bad. So it's better just to err on the side of caution and just play it safe. But that's that. Cabling and connectivity, just how it sounds, setting up your HDMI cables, setting up your Cat5 cables, so on and so forth. Device configuration, what we just talked about, testing and validation. So testing and validation is this is one of the most important aspects within security, is your testing and your validation. It goes back to, again, your use cases and success criterias. You always want to test everything. You want to have testing procedures and processes. You want to make sure it's safe because, again, when it comes to security, if you're not testing the security that you're implementing, you can cause a lot of problems. You can go bankrupt, you can get hacked, you can get ransomware, you can get all types of really bad things. So you test against these things to make sure that, it's not if, but when it does happen, you are protected. Again, documentation as well. This is incredibly important when it comes to policies and procedures and documentation. This is the backbone of everything. Documentation is always going to be a little bit different, again, depending on the company and what the company does, the industry. The military and government, as you can imagine, their documentation and their bureaucracy and their policies and procedures is taken to the nth degree, and it's insane, and it's a lot of overhead and a lot of paperwork, but I guess it kind of has to be that way, right? So to make sure all the bases are being covered. Gradual implementation of a new network can be done gradually to minimize disruptions in normal operations. This involves progressively migrating existing services and devices to a new network. So that's just a term used to where when you're, again, scaling something out, implementing something new, you're doing it gradually over time and like an agile type development, to where you're not just overloading the system and adding a bunch of changes all at the same time and potentially opening yourselves up to, a lot of problems and a lot of potential security flaws and everything like that. So slowly working your way up to implement the scalability you're looking for. Maintenance and monitoring, as we talked about before, making sure that availability and security is there, applying security updates and troubleshooting as well. Sorry, did someone have a question? And training of personnel. Training is, of course, incredibly important. Anytime anyone goes to a new job, we all get training, especially in IT and security. Usually there's designated trainers. I've been a designated training person at companies I worked at. I've created the training programs and procedures for new and current employees and everything like that. But training is critical, especially in cybersecurity. Anyone will tell you that's familiar with cybersecurity, who's been involved in breaches, that the number one biggest threat to any company is actually the employees. Oftentimes, employees, through non-nefarious acts, by accident, they are responsible for some of the biggest breaches and some of the biggest downfalls of a company, just through lack of education, right? And not knowing what they're doing, potentially going to a website and downloading something that is malicious, that completely destroys the network or environment. So usually you'll find a lot of times when it comes to your cybersecurity attacks and your breaches that occur with companies, they're often due to employees that work there, through really just lack of lack of education and not knowing what they're doing. So security training is critical for many reasons. And finally, implementing a network architecture in an enterprise is a complex project that involves several teams, including engineers, administrators, and cybersecurity experts. Careful planning and proper documentation are essential to the success of the project to ensure that the network meets the company's objectives. And so that's kind of what I do in my civilian job. As a security architect, I work with network engineers, I work with the admins, I work with PMs called project managers, and I work with them to build out solutions. So an example would be a company needs to implement endpoint protection. I'm sure y'all have heard of like Semantic or McAfee, but EDR, endpoint detection and response. So my role would be to design the implementation of being able to have X amount of computers on the network and bring in an EDR component to protect their endpoint, and all the project planning that involves with that, all the administrators, all the network engineers, all the PMs, all the architects to make that happen, and putting together, your roadmap. And so looking at a big picture, that's how all this stuff comes into play. So that was a lot of words there. Who has questions? All right. I either lost you guys or I'm just really good at teaching this stuff. All right, we'll go to the next one.
I have a question.
Yeah.
So the example you gave is if a company had an architect and had a team and you had to build a security for their access without corrupting or putting other departments at risk by combining them, by making small groups. Essentially, is that what we're doing as cybersecurity guards?
Yeah.
Is creating these spaces?
Yeah, that's part of it. So within cybersecurity, there's so many different areas of cybersecurity, right? You mentioned pen testing, right? So there's pen testers who test the security of a company. They'll try to hack it. They'll try to identify vulnerabilities and exploit them. You have people like architects like me who will go into a company. They'll do an assessment and what's known as a gap analysis. They'll identify weak points, and then they'll make recommendations and implement solutions to address those weak points. Then there's your basic day-to-day incident response. So oftentimes you'll have a team, and that's specifically more within the enterprise, large scale companies, incident response teams who are specifically designed and structured to address some type of hack that occurs. So if a company gets compromised, you have your incident response team that goes and addresses that and goes through the whole incident response procedure to correct whatever attack has occurred. Then you have something like vulnerability management, where you have a group or team of people who are responsible for day-to-day operations and ensuring that all the computers are patched properly, that all the security updates are applied properly, that the scanning is done to identify any gaps as well. So there's a whole lot of different teams. There's a whole lot of different areas of cybersecurity that one could really focus on. So that's, to answer your question, that is one little aspect of it. Yeah. And then there's groups of people that specialize in so many different, and that's just a small fraction. I could go on, for the next hour in different areas, but yeah. And that's really what's cool about cybersecurity, is that there's probably been at least, 10 different areas of security that I've been involved with over the years. And they all are associated with security, but they all do different things, right? So I've been a part of incident response. I've been a part of vulnerability management. I've been an architect. I've been day-to-day, just a security admin doing the basic patching, asset management type of stuff. So depending on what you like to do and what you're really interested in, you really have a whole, group of different areas you can really choose from. Some people like to work with customers and work with customers and build out things for customers. Some people like to work behind the scenes and do stuff behind the scenes. So it's really, there's so many different things. It's really, what do you like to do, and what is it you want to do, so there's a lot of freedom in that. Does that answer your question?
Yes.
Cool. All right. Basic network security. So let's see. We only have 1 hour left. Is that right? Yeah. Okay.
An hour and 5 minutes.
An hour and 5 minutes. All right. I'll run through this and then we'll get started on what do y'all want to do? The project's going to take longer. Do you guys want to, we can go through these, we can do these quizzes together. I think they're only, there's 2 of them that are 11 questions. That'll go quick. But however y'all want to do it, we can do the quizzes together. Y'all can do the quizzes on your own. We can do the quizzes first and then do the project, or we can do the project first. I think the project is probably going to take about 20 or 30 minutes. So I'll let y'all think about that for a second, and I'll start doing this one, and then we'll figure that out when it gets to that part. So
I say project and leave early.
Hey, I'm good with that. This is y'all's time, so it's up to y'all. So basic network. So now we're finally getting into security. So firewalls. Just in short, when y'all did your pre-work stuff, did y'all cover? I'm not familiar with the pre-work, but did y'all cover stuff like this already? Did y'all get some basic understanding of this stuff? Okay, cool. So do firewalls make sense to y'all? Do y'all need me to break it down in super detail, or y'all understand it for the most part? It's pretty straightforward, but a firewall network security system, again, that usually sits at the front of a company, and that's your first main, just as it sounds, it's like your firewall, it's your wall. Anything going past that wall has to be checked. So if you want to go past that firewall into the corporate account, you need to make sure that you're able to meet certain security requirements and expectations. There's different types of firewalls. The most common out of all of these, packet filtering firewall, gateway firewall, stateful, those are all the same thing. The next gen firewall, that's pretty much when you're talking about firewalls in the industry, and a company or a customer comes to you and says, I want a firewall. 9 times out of 10, it's next gen firewall. NG is how they say it. NG firewall. That's what you're going to be looking at. And there's literally probably 50, 60, 70 different vendors out there on the market that provide next-gen firewalls. Some of your biggest are like Barracuda, Palo Alto Networks. Those are usually your go-tos. Some of these we're going to cover. They're not even really a thing. It's next-gen firewall. That's it. That's because it provides that's the most current technology, the greatest technology. That's what the standardization is. That's what people go for. There's also something known as stateful and stateless firewalls, which I'll talk about in a second. But in short, stateful means that it's inspecting every single packet that comes through. Whereas a stateless, it just allows every packet to come through, and then it distributes it as see fit. But the standards now are next-gen firewalls with stateful inspection packet filtering. That's the standard across the board. So a firewall is a network security system that restricts incoming, outgoing, and internal traffic within a network. The term comes from the concept of physical walls that act as barriers to slow the spread of fire. Firewalls can be software or a dedicated hardware or software unit that works selectively. So that's what I talked about just a little bit ago, to where a firewall could be virtual software or it can be a bare metal. Nowadays, for the most part, unless, again, you're military or government and you have to abide by a compliance mandate, you're going to have a bare metal, a dedicated firewall. And the reason why you want to avoid those is because of cost. They're often very much more expensive. When it comes to scaling them, it's much more difficult. when it comes to having to replace them, there's much more cost associated with it. So if you can keep it virtual in the software, that's the way to go. It's cheaper, it's easier to manage, it's easier to scale, and it provides a lot of benefits in that sense. Simpler explanation to consider them is boundaries are gates on a private network or host devices to manage the flow of activity. Again, the role of firewalls in a network, protect the entire computer network, controlling data traffic, acts as a barrier between internal and the outside world, filtering and blocking unauthorized, dangerous access. One of the most important functions is intrusion prevention, detecting and blocking. So when people talk about IPS, IDS, firewalls, they're talking about the same thing. Intrusion prevention, intrusion detection, they're all doing the same thing. They're validating ports and protocols and packet inspection to make sure it's safe to enter into the corporate network. And most importantly, firewalls can prevent the denial of service attacks. Are y'all familiar with DDoS attacks? Do y'all understand how those work? Yes, no, yeah. Okay, so just in short, DDoS attack basically means one of the ways a hacker may try to bring down a server or system is they'll overload that server. And so they'll send a bunch of requests to that server and make it unable to function as a normal server. And so by flooding it with the denial of service DDoS attack, you're preventing other users, normal users, from going to access that server to do normal stuff. And so you're essentially bogging it down and preventing people from using the services. And that's why disaster recovery and high availability are so important, is because if that server is getting DDoS attacked, you just do a failover and then it goes to another server, a different IP address, and you're good to go. Nowadays, DDoS attacks are pretty much they're not very successful because of the technology and security technology available now. They're easy to block. It's a lot easier to detect, and it's easy to block those IPs that are trying to flood that server. So how do firewalls work? Again, separating good traffic from bad traffic, protect private networks from point of connection devices. Computers and other point of attachment devices use networks to access the internet. However, the internet itself is segmented into subnets. In a firewall, traffic filtering is achieved through preset or dynamically learned rules. So you have a firewall that's going to have a set of rules associated with it, and that's how you determine what's going to be allowed or not allowed to enter into your network. Regardless of the type of firewall, can perform filtering using a combination of the following. So your source IP, where did it come from? Your destination, where is it going? And content, what is in the body of the packet? What type of information is it? Packet protocols, the language used to transmit the message. Among the network protocols that hosts use to communicate with each other, TCP protocols are primarily used to communicate over the internet. So again, TCP IP protocols, they use packets, which we talked about. And in those packets, that's your packet of data. That's how we communicate. That's how I'm communicating right now. The words that I'm saying into this microphone, what ends up happening is I say the words, and then the computer will encapsulate that into a packet of data, and then it'll transmit it over to the wire, and then it'll allow your speakers to encode it and present the information.
How many times does that happen per second?
Oh, a lot. It's nonstop. It happens milliseconds. It's just nonstop. Yeah, I mean, more than the human brain can comprehend. So again, common protocols: Telnet, FTP, DNS, SSH. Firewall types include various filtering methods. So connection tracking, filtering rules, audit logging. So packet filtering, filter packets based on network addresses, protocols, and ports. Again, the rules associated are set according to the access control lists. The inability to read application protocols means that the content of the message sent within that packet cannot be read. Without reading the content, packet filtering firewalls have limited protection. Gateway firewall. Check the functional packets in the connection attempt and if successful, allow persistent open connection. Stateful inspection firewalls, also dynamic packet filtering, compared to static filtering, is the ability to monitor ongoing connections and remember previous connections. They started out acting at the transport. These firewalls can monitor many layers, including application. Like static filtering, stateful inspection allow our block traffic based on technical properties, such as specific packet protocols, IP addresses, or ports. Then we get into our next-gen firewalls. The constant evolution of threats requires more robust solutions. Next-gen firewalls overcome by combining functions of a traditional firewall with network intrusion prevention systems. Another thing that next-gen firewalls really capitalize on is AI and ML, so machine learning, being able to infer basic functions and capabilities of previous actions and determining whether or not that can be safe for future transactions. Wireless network security. So Wi-Fi, I'm sure we're all familiar with Wi-Fi networks, frequency, connection by transmission instead of cables, reduces the speed of connection or create vulnerabilities in situations such as identity theft. Encryption. So encryption of a wireless network is used to add security through an authentication protocol, which prompts for a password or network key when a user or device attempts to connect. And we're all familiar with that. We all put in our password or whatever when we need to connect to the Wi-Fi. If the Wi-Fi is not secured with some form of encryption, it's possible that an unauthorized user can access it and obtain personal information and reduce the speed and performance of that network. Different types of encryption. So WEP, wireless encryption protocol, uses a secret key shared between the access point and the host. The 802 standard does not specify how the private key is established, but allows for a table that associates the unique key to that station. WEP provides two types of authentication. Open system, where all users are allowed, or shared key authentication. So an example would be going to Starbucks, and they have a Wi-Fi that anybody can connect to. Anybody's allowed to access it versus one that's probably your personal one where, you know, unless you have that specific password, you're not going to be able to access it. Of the two levels, shared key authentication is the secure mode in which a private key is shared between all stations and access points. To protect encoded text from unauthorized modification while in transit, WEP applies an integrity check algorithm, CRC32, in plain text. Shared key authentication works only if WEP encryption is enabled. Otherwise, the system will revert to open system. WEP uses the same symmetric and static key at the stations and the access point. The standard does not provide any automatic key distribution mechanisms. On the other hand, the manual distribution of keys leads to increased maintenance of the network administrator. So Wi-Fi protected access, so WEP, WPA2 is your standard. WEP isn't used very often. WPA is not used very often. Those are the more insecure ones. WPA2, that's the most secure. That's the one that all current technologies use. So WT is a Wi-Fi encryption protocol that was developed to solve vulnerability problems detected in the first version of WPA. WPA specifications are not public, so the amount of information available is really scarce. It's also known as WPA2 and AES, Advanced Encryption Standard, encryption algorithm developed by NIS. As already mentioned, this is a Wi-Fi block cipher algorithm, 128 key bit. Powerful hardware is required to perform WPA2 algorithms, which means that older devices without sufficient processing will not be able to incorporate. PSK, personal mode, or pre-shared key, works in the same way as WPA security and is the easiest Wi-Fi encryption protocol to install. MAC filtering. Media access control. The purpose of MAC filtering is to restrict network access to a specific device or group of devices. Does everybody know what a MAC address is? So every computer, device, server, hard drive, it's going to have a MAC address, media access control, and that's a specific. Think of it as a social security number of an individual. Same thing for a piece of hardware. It's going to have that number that specifically identifies it, and that's another added layer of security. So when you're creating rules and firewalls or whatever the case may be, you may say we only allow this specific MAC addresses to come into the network. Does that make sense?
Yeah, I think
Yeah.
it does. I'm sorry, Yuki. Wanna go?
No, I was saying yes, it makes sense.
Okay. Yeah. Does a Mac, is it like a number and like an address and like a number? Yeah. I saw that on my mom's router when I was hooking up for Xfinity yesterday.
Yeah.
So familiar.
Yeah. Think of it as like a social security number for a human. It's the same thing for a device.
Is it physical and digital or just digital?
It's a physical number on the device, but you could see it digitally, like when you look it up on your
Yeah.
computer or something. All right.
Like when I was connecting the network, like you said, it says it's to restrict network access. So I had to put in that MAC number in the app to like block everybody from coming in to steal our Wi-Fi.
Yep.
Yeah.
Exactly. All right. So we got through all of the talking. So this project right here, I read over it. It doesn't look too difficult. It says create a text document with the answers to the questions and the instructions. Once you have your document ready, upload it to. So do you guys want to use, how do y'all want to, you want to use Google Docs? I've never done this before. So maybe what we can do this time, if it doesn't work, is y'all can use Google Docs. And we'll go through the answers and you can just save it and we'll try to upload it through the Send project. If that doesn't work, at least we can save it, and then y'all will be good when I figure out from the instructors where they want to upload it. At least y'all have the work done, and you won't get dinged or anything.
This one is similar to the one that we did in the pre-work, right, Yuki? You did the pre-work, right?
Yes, I did do the pre-work. Hold on.
Yeah, it's very similar, and the way we upload it is when you press Send project. So I think it's connected to one of these apps that we had downloaded. I don't remember.
Oh yes, it's completely identical.
Yeah.
Oh,
So
okay.
it's connect. Let me go on my other app. I'm using like 3 different screens right now. So I think it either through Virtual Studio Code. I think we use it through, or either Cisco Packet Tracer. So we uploaded it through one of those.
Okay.
Yeah, so you should already have our projects. But it looks like this project.
Maybe it's a different, I think it's a different one. It's just set up the same way like the picture, but how we have to connect it, maybe it's different. I don't know, but we did something very similar to this one.
Did y'all have to upload anything before? Like what y'all did? Okay.
Yeah, so I think once we press Send project, it will show you like the next option. Because once you finish the project, you're gonna save it on your computer, either through Cisco Packet Tracer or either, I don't think it's Oracle. I think maybe Visual Studio Code or something. One of those. I think it's Cisco.
So you need to do that just for a text document? You need to use that
No,
stuff?
so well, we download it on our computer, and I think that's what we use to send the project.
Okay.
Yeah, Visual Studio Code.
I think it's probably Visual Studio Code. So once you click, let me see. Let me show you. Let me go on it.
Yeah, if you want to share your screen. So you're saying we can't just create a text and then hit upload?
No,
okay.
Let me show you. Okay, so let me share my screen.
All right.
Well, let me log in first because I'm using let me see, 4 gigs. I'm using a different computer. Okay, so I'm gonna share my screen now. Windows. Okay. Can you see my screen?
It's coming up. It's trying. Yeah.
Okay. Wait, let me see. All right, so what we're here, the project. Can you see my screen, right?
Mm-hmm.
Okay. So once we click on this right here, send project, then we upload it right here.
Right.
And then when we upload it, wherever it's saved, you click on it, and then we just upload, and then it's gonna ask us to confirm. You confirm, and then we send the project. So that's
what
the
were
way.
you talking about those application things you were saying? The
No, I thought we had to send through that,
it's a
but
different.
that's what
Okay.
I did before. And then when I called my mentor, and then she had helped me through doing this. So it's just once you go through the I think Yuki, let me.
Yes.
Can you help me out? I think didn't we do something through once we opened the project? Didn't we do it through Cisco Packet or Virtual Studio Code? I think we did through one of them.
Looking at the history of my activity,
Yeah.
it says tutorial. Sorry, that's all magic. Open folder.
Let me go in Cisco. I think it was
I
Cisco.
have Slack 441 DMG get Cisco packet tracer
Yeah.
822.
Yeah, that's the one that we did it through. I'm pulling it up right now.
Yeah, I just double clicked mine.
Let me see.
Let me open mine up.
So we had saved it through here. Well, we did the project through here. So
Yeah, actually, we use the Cisco packet tracer, and the diagram you have, this diagram you have up here, this was exactly something we created with this packet tracer, and we uploaded. But
Yeah,
this
but
very, yeah,
if you look at the instructions,
yeah,
it says the company has the following requirements. So it
right,
looks like we have to expand on the project that we already did.
exactly.
Oh.
Mhm.
That's what I'm seeing or getting from it.
Well, maybe.
Can Teresa, do you mind showing me what you already did once before? Did you fill something out on a text document already?
I'm actually looking.
No, we didn't create any text document. Rather, the Cisco packet tracer was something. It was an application we kind of went into, and we brought out all these devices,
Oh,
and we connected them.
I got you.
We connected them, and it
So I
was
think
just
that's
for
gonna
this.
be the next. That's gonna be Wednesdays. It says network troubleshooting packet tracer. So I think we'll be doing that one on the next lab.
So what is this project that we're doing?
So this one is just, it looks like questions 1 through 8. Let
me see.
So it says the network should have the capacity to grow 100 devices. You have several subnets: marketing, technology, and accounting. You have 30 in marketing, 40 in technology, 15 in accounting. The remaining is reserved for future growth. So that's 70, 85. So that's 15 left over. Each subnet should have its own private server. Only the technology department should be available. So assessment: what is the extent of the current network? I mean, I would say you have roughly 100 different devices that need individual servers, or you have 3 departments that need individual servers that can only communicate with each other, something along those lines. Do y'all see what I'm getting at?
Yeah. So it This would be a lot easier if we had the same. Hold up. If we go back to
The old one.
go back to dashboard. And then go back to the pre-work.
Yeah, that's what I'm doing now.
And
I'm
then
in the pre-work and
go
I'm
to the
trying to see.
practice. Then it says learn Python. I'm not trying to do that. Welcome to GitHub. Instruction, packet tracer. What's it? Packet tracer?
Yeah.
Packet tracer.
Yeah, the Cisco packet tracer is what we went through. That's what we used to open the project.
Yeah.
That's what we had to do the project and then save it. And then after we saved the project, then we went back and then we uploaded it.
I think the requirements kind of here is just like a continuation of that project, but an analysis of the project we did.
Probably.
Because then we just did the design. We just placed the devices and connected the devices, and that was it. We didn't do nothing. We didn't write anything. There was no analysis of anything. But right now, what I'm seeing here is like,
okay, I have it up on my screen. Let me share it. Let me share my screen.
Yeah, so the packet tracer one we're going to be doing on Wednesday. So
entire screen.
Sounds like you already did that one.
Is my screen sharing?
No.
Huh? Why can't I share?
Maybe only the admin can share a screen.
I just shared my screen earlier.
Oh.
I don't know. Wasn't my screen sharing earlier?
Yeah, you had it up earlier.
Yeah.
Shared earlier.
Am I using the right one? Yeah. Let me touch it. Oh, there it is. Is it working now?
Yeah.
It's coming up.
Actually, Pitts is up.
So this is what we did. So first we had like this little thing right here. It was this.
You talking about this, right?
Yeah, this is what we did. We had to connect them.
Yeah, so this is what we
had to
do for the pre-work, but because it was our duty to do this, they provided
the instructions.
The download here. But if you go to back to our course,
this one.
Project here, it does not provide it.
So there's nothing to click on. You know, like normally you click on something, or maybe it says edit in GitHub. So maybe wait. Oh, so I think we have to complete the project in GitHub then. Because there it is. So that's what we have to do. Yeah. Because when you go here, it's like right here where my thing is, my cursor. Because I think all of our project has to be downloaded to GitHub. That's why when we started, they asked us to download GitHub and packet tracer and like Cisco and all that stuff. Because we're going to use, I think all of our projects is going to go in GitHub.
Edit in GitHub.
What the GitHub link we give you is the URL for the
where people can view your project.
So
I think that's where we have to complete it so people can view your projects there, is what I'm thinking.
Preview code plain. But where would you? That's just a picture.
So if you scroll down, How to deliver this project right here. So create a text document with the answers to the questions. So those are the questions 1 through 8. We have to answer those questions. Then we put it on a text document and upload it to here, send project. It's really that simple.
Oh, so like the same thing that we did in the project before, but we have to just write a text document, like type
Just
it out.
answer these questions. Yeah.
So we're not clicking and dragging and creating.
That's Wednesday.
Sorry.
We
Okay.
do that Wednesday. Yep.
Okay.
Okay. All right. That's easy enough. That was unnecessarily confusing.
So how about this? Do you guys want to go over? We can do the quizzes together, and then I'll leave y'all with the project, and y'all can upload it when y'all are done. Or how do you want to do it? I'm good either way.
Well,
we have
if you
30
go over the quizzes, each of us are going to have a different quiz.
Oh, is it? They're all different. Oh, okay.
Yeah, every time you.
It's the same questions, but it's like it will come up in different order.
Different order. Yeah.
So maybe if like you share your screen and do it, maybe we can answer from there. But each
Yeah,
time,
I
like when
can
we
do
go
that.
in, it's gonna be separate. You can stop sharing.
So y'all want me to do that? Share my screen, and we'll go over the quizzes, and then y'all can just find the answers. And because I want to make sure y'all get y'all stuff submitted on your side, right? So that's what I'm concerned
It
about.
is so dark in here. Oh my god.
I mean, we can do it as a I don't know. Well, it's just an option. Well, it's just an opinion. We can do it as maybe as a team, and then we can do it separately on our own.
Okay.
You know,
Yeah. Okay.
if that's okay with everybody.
No, I'm good with whatever.
Abu, what do you think? Do you want to do it on your own, or do you want to do it as a group, and then we can do it on our own?
Yeah, if we do it as a group, I think it'll be more beneficial.
Yeah.
Because different opinions and learning from one another. That's
okay.
my own.
What do you think, Yuki? Is that okay with you?
Go over the quizzes.
Yeah, together as a group, and then we can do it on our own, because it's not like I think the quizzes, like they said in the start, is not that important, just for us to learn whatever we went through.
All right, I'm down.
Yeah, like it says right here, there are no wrong answers in terms of network. So what I'm thinking is we'll just go over. We'll go over these, and then I'll provide what we can all say what we think is the right answer, and then y'all can put that stuff in on your own if that's what y'all want to do.
Yeah, we can do that, and then we can do it on our own. So it will show up in, or maybe we can get the answer, then we can just answer right here and get 100%.
All right. What is a computer network, and how has it evolved? Device that controls network traffic, a set of connected devices for sharing resources and community, a type of antivirus software, no, a method for encrypting information sent over the network.
A set of
I would say
connected devices.
B, yeah.
What was the answer?
A set of connected devices.
A device of connected devices. A device that connects two different networks, where did it go?
It's a different one. I don't think you can go back.
Okay. What are communication protocols, and how do they work in networks? Communication protocols. A type of software that projects against. No. A device. No. A set of rules.
No, don't answer for us. Don't answer.
No,
I'm just reading them out. So
Let us answer.
So let me share some knowledge with you guys, because I was trained. I was taught when by the military when there's a protocols that are used in creating tests, right? And military loves tests. And so one of the things they teach you when creating tests is that automatically right out the gate, no matter what, there's going to be two answers that are just completely wrong, right? Yeah. So the goal is to identify those that are automatically wrong, 50, and that automatically puts you at 50% of being able to get the right answer. So what you want to do is that process of elimination. And so getting those that you know are completely wrong, and then having those two to choose from. So that's
Okay.
how I do it in my mind. So that's yeah.
Thanks for the tip. I think that's how. Yeah, that's how it's supposed to be done.
So what do y'all think for this one?
Okay. Did Abu leave? I think he probably got disconnected. What
Yeah, he left.
protocol and how do they work in networks?
So when it says right off of here, what are communication protocols, you know that it's not going to be a device, and you know that it's not going to be software, because a protocol is not either of those two things, right? So
How would they
automatically you have between these two. Yeah. So
see?
A method of segmenting the network into different security zones.
Yeah.
What was that?
No, that's wrong.
Well, this is a different one. Okay, what is the network topology and what are the main topologies?
So right off the bat, A is
That's
out of the
wrong.
question.
I know that one. I was.
It's C.
Stores.
I mean D.
No, wait. Don't go here. The way device.
So right off the bat, you know it's not a device.
I was gonna say no. I was gonna say B, but
I said B and it said it was wrong, so I went with D.
Oh. Also, you're doing it on your end too.
What are servers and what functions do they perform?
Let's see. Let me see. See. Device
It's not a method.
Network.
It's definitely a device.
B or C, exactly.
Yeah. So and that's the other part I forgot to mention is that automatically two are going to be discarded. They're going to be, so that leaves you again at 50%. And then usually those two leftover answers, they're actually going to be both right to some degree, but one's going to be more right than the other, believe it or not.
Yeah.
That's how they do it.
We're seeing it right now. Exactly.
Devices that offer services, resources, and data to other devices on the network.
Okay, what are some types of servers? Okay.
Common types of servers and their functions.
Oh, that's all of the above.
Proxy server, game server, chat server, print server, storage server, email server.
All of the above.
Yeah. What are network reference models and why are they important?
Network model.
Is a reference model a set of tools? Is it physical devices? No.
Theoretical frameworks for understanding network communication and organization.
Yeah. Oh, did we lose?
Yeah.
Okay.
Yeah, we lost him like 3-4 minutes ago.
Oh, okay.
More like 5 minutes ago. It was gone. I don't know where you went.
What are the main layers of the
Maybe
OSI
it's thing died. Well, let me see. What are the main?
OSI. I forgot what OSI means.
Open source interconnectivity.
Open source interconnectivity model and the functions.
Options 1 and 2. So is this option 1? This first one?
Option 1 and 2 are correct. Maybe all of the above then.
All the above.
Yeah.
Oh my god.
How did we get that one wrong? How does the TCP differ from OSI? There's no significant difference. The TCP has fewer layers than the OSI. Focuses on architecture. OSI is more commonly used in practice than the TCP. No. What do y'all think?
What didn't you talk about that?
Yeah. The TCPI, that's only 4. So that's your network, session, application, and presentation.
Where are you going? Huh?
Isn't that what you do, Mr. Cody?
What's that?
Architecture of the internet.
Yeah, but this is a little different. Yeah, mine's more for security, but
B.
OSI is more commonly used in practice than. You want to go with D? What do you think?
Let me see. Oh, it's not B. I was saying B, but just don't click it. If it's wrong, don't click it. D. More
B?
commonly used in the practice. D.
Oh.
Maybe it was B.
Oh.
I'm gonna read over this again tonight.
What function does the transport layer serve? And transmitting data across the physical,
What function then?
presenting data. So presenting data at the application and representation, routing data across different networks. Physical data.
D.
Yeah, I want to say D2. What do you think, Teresa?
It's not. Is it physical network? No, routing data across different network, presenting data. I know it's not that one. I know it's not 1 or 3. Transmitting data across the physical network. No. I'm gonna go with D2.
D. Oh.
Jesus. What example are protocol? What examples of protocols are found in application?
Yeah, this one's a little tricky. So TCP, that's going to be your transport. That's going to be your session and transport. ARP DNS, that occurs at the lower levels. Your presentation or your data and physical layers. So I want to say this. We still passed.
I know, right?
I got 6 out of 10.
You were counting?
No, I did it on my end.
Oh, okay. I didn't do it on my end yet.
All right, let's do this one. What is network architecture and why is it important for a company? Type of software? No. Physical device that enables internet connection? Structured framework for design, implementation, and management? A set of tools? Yeah.
Mm-hmm.
What are some key elements that typically form part of a network architecture? User application network. Yeah. What? They said no, dude. You got it wrong. Wow.
Oh my goodness, I'm surprised.
What steps should be followed to design and implement a network architecture in a company? Define the topology, choose the components, configure the devices, identify requirements, select the topology, plan the security. Install the wiring? No. Train the staff? Document? No. I think it's going to be one of these two.
Plan this.
Normally, you want to identify the requirements. That's step 1. Yeah.
Oh, yeah.
Why is documentation important in a network architecture? To comply with security standards, to facilitate network management and support, to have historical record? No. To save costs? No. To facilitate network management and support. Wow, these both are good answers.
Very tricky.
To facilitate network management. Well, since it's saying why is it important for network architecture, network management, maybe that's, the key there. What do y'all think?
I'll probably go with that, yeah.
Which one? A? B?
B.
What is gradual implementation and why is it used? So we talked about that one. It's the manual configuration of each device. No. It's the simultaneous installation of all network components. No. It's the progressive migration of services and devices to a network. Yes. It's the testing and validation of network before implementation. What do y'all think? Which one?
C.
See? Teresa?
You already gave us the answer. You said yeah. We already need. Welcome back, Abu.
Hey, thank you. My computer just died on me.
I know. I figured
Oh,
like your computer
glad you're
probably
back.
died. It's gonna take time to.
What is
the answer
the
again?
for the last one?
Yeah.
I wish we would go back. It's the slow implementation, one at a time, and so you don't bog down the system, basically.
Yeah. What is the main function of a firewall in the network?
Controlling data traffic entering and leaving the network, sharing files, storing data, connecting devices. So connecting devices, no. Storing data,
Number
no.
one.
A.
Sharing files,
Yeah.
no. Yeah. What type of firewalls exist and how do they differ from each other? All firewalls work the same way? No. There are only software.
Definitely not that.
Packet filtering
Packet
only
filtering,
analyze.
yeah.
Next gen
Yeah.
firewalls are not
C.
necessary.
C.
What security measures can be taken to protect a Wi-Fi network? Sharing the password with all neighbors? No. Using a complex and secure password? Maybe.
Yes.
Disabling the
Yes.
encryption? No. Leaving the network open?
B.
This one's a lot easier. What are the advantages and disadvantages of using a SSID and a firewall? So we didn't cover this. I don't think so.
Asshole.
Let me look up.
Anyway.
I don't even remember seeing this SSID.
Straight dicks.
Service set identifier, unique name used to assign a Wi-Fi network, distinguishes on a network from another. Oh, okay. Yeah. All right. A hidden net can make it difficult for some devices. A hidden net is not compatible with all routers. A hidden makes the network completely invisible. A hidden does not offer any security improvement. So, no.
What does SSID mean?
It's
Social Security.
yeah. Service set identifier. It's a unique name assigned to a Wi-Fi network. It distinguishes one network from another.
Okay.
Basically, it's just the name of the network. Yeah. So, a hidden SSID does not offer security. No, it probably would. A hidden SSID makes the network completely invisible. Probably. A hidden is not compatible. No, a hidden SSID makes it difficult for some devices to connect to the network. So that could probably be true as well, but I think that's probably the better.
C.
That's
That's
the
what I'm
answer.
thinking. I'm thinking C.
That's the answer.
It looks more like C.
It's A.
I'm thinking C.
I told you A. I told you A.
It's too late. I already put it in. That's my bad. What is a VPN and what benefits does it? So, what does VPN stand for again? Virtual private
network.
Yeah.
A VPN hides your IP addresses and encrypts your data for added security.
D. Wait, let me see.
A VPN is a private network for file sharing. A VPN is not compatible with mobile devices. No. VPN only works on private networks.
A. It's A. That one I know. A.
Which one?
A, number
hides
one.
your
The first
IP
one.
address and encrypts your data for added security.
Pitts, you good with that?
Yep.
All right, good answer. What does the acronym? So we didn't cover this. That stands for demilitarized zone. Let me. So this is the answer. Let me show y'all what that actually looks like.
Like a no-go area.
No. So can y'all see my screen?
Yeah. Yes, we can.
Yes.
So a DMZ, basically, it looks just like this. You're going to have your internal network right here, and you have your own firewall, but you have a DMZ that acts as a partial internal network. And so your DMZ, you're going to have stuff that's a part of your internal, but not all of it. So it's basically an added security. So when a user wants to access something on the network, they don't have to go fully inside the network to get it. They have a mini network kind of in front of it that provides a little bit of information, but not all of it. And you can access it within a DMZ zone. Does that make sense? So in other words, instead of just going directly into the whole network and having access to anything and everything, you only have selected stuff to prevent, a massive breach. Get it?
Yes.
All right. All right. So that's it. What do y'all want to do? You have a few minutes left. Y'all want to work on this part yourself, or what do y'all want to do?
Well, my suggestion, we can work on it on our own over the next day, and then we can follow up on Wednesday.
I was just gonna say, if you want, we can take a few minutes and we'll go over these questions and get an idea of what y'all think, and then y'all can go back and on your own text and you can fill in the blanks if y'all want.
Okay.
Okay. So
wait, we need to Abu and Yuki, we need to start a WhatsApp group so we can ask each other questions.
Yeah, that's good.
Yeah,
we can do like a WhatsApp group. So
you don't use Slack?
Yeah, we can create
yeah, we can use Slack. Yeah.
We can create a group on Slack.
Yeah. We can do that. Yuki, want to create a group and add us?
I'll do it right now.
Yeah.
Okay. So the first question is, what is the extent of the current network? And it tells you right here, everything. So you got 100 devices total, and here, this is how it's broken down.
Okay.
And then it says, what problems can be expected if there are no improves to the company's network? So if you don't add segmented networking, which we talked about, where you're breaking up these different departments into different groups, if marketing gets hacked, technology can get hacked, accounting can get hacked, and everything else. And so by not implementing the subnets, you're essentially doing what's called expanding your attack surface, meaning you're creating more problems than needed. In short. So network topology. What network topology would you use for this company? I'm going to say mesh. You want backup and redundancy is the primary reason. How should devices and servers be connected via mesh configuration? Network equipment. What type of network devices are needed? So they already mentioned it right here. Routers, switching, firewalls. Yeah.
What technical specifications must these devices meet?
Then it says, what technical specifications? So every firewall and switch is going to be different. The way I'd answer this is based off of current best practices and standards. That's kind of the default. So there's no universal answer for the best technical specifications for any one of these. They're always going to be different, and it's really just based off of what the current industry standards are. Network security. What are the security measures required to protect the network? So I'm going to go with network segmentation, which we talked about before. And let's see what else they're saying. Making sure that you're using the right firewall. for the requirements. So if you have Wi-Fi, you want to use WPA2. If you have a bare metal, some type of
WPA2.
if you have some type of firewall requirement, you're going to want to use next gen firewalls. And then how should security devices such as firewalls be configured? And then based off of the requirements of the infrastructure and based off of the current best practices and standards. All configuration rules are going to be different based off of the requirements of the organization. Network management. How will network devices be managed and monitored? That's kind of open-ended question. What do y'all think for that? It's kind of a vague. I would just say basic network management involves network monitoring, configuration, maintenance, and troubleshooting. Network management tools are used to facilitate these tasks, and there's hundreds of different network management tools available. So that's kind of a really open-ended question. What policies should be implemented in terms of personnel to have a secure network? You want to implement best practices, policies, and procedures. Every single one of these are always going to be different depending on the organization.
Abu.
Well, can we say here, when you're talking of policies now, the need to know basis or the least privilege? I don't know. Do you think any of those policies fit?
Yeah, the thing is, I mean that's at least sure, and there's so many different policies and procedures. There's so many different ones. Your most basic ones are like anytime someone new goes to a company and you're given a company laptop, they say you can't go to gambling websites, you can't go to malicious websites, you can't download this. They're always going to be specific to that company. Will a network management system or monitoring tools be implemented? Yes, you should always have network monitoring tools in place. Implementation plan. What is the implementation schedule for proposed enhancements? Again, this is always going to be different. So in short, you work with your PM, your program manager, and you develop a project plan that's going to identify your stakeholders, your milestones, your budget, your key stakeholders who are going to be doing what their titles are, what the different objectives are, what your use cases and success criteria are. So that's a really open-ended question. How will these changes be communicated to employees? Usually they have...
Could it be training or change management?
Yeah, so you have change management, you have tools like ServiceNow, but you also have various project management tools too, like drawing a blank. But basically it's different project management tools, and there's a whole bunch of them out there. And basically it just breaks down timeframes, again, objectives, task, who's responsible for doing it. And that can be in Excel spreadsheets, that can be a specific application. Yeah. Ongoing maintenance.
Yeah.
Can you type in your email so I can send you the requests on Slack?
All right, let me do that now.
Thank you. Sorry about that.
You're good.
What steps will be taken to ensure ongoing network maintenance and upgrades following your basic project plan? What security policies and incident response procedures be established? And they didn't talk about this stuff in detail that we covered. So
is there?
Thank you.
Finally, evaluation of success. How will the success of the enhancements be measured? What metrics will be used to evaluate network performance and security? So during your project plan, you're going to create KPIs, key performance indicators, and based off of your success criteria, are you meeting those objectives in the specific time frame within budget? That's how success is really measured. And again, they didn't really cover this in any of the material that I saw, so it's kind of open-ended. Okay, who has questions?
So I think so. We have to get this. We have to do a text document and upload to 4geeks.com platform.
Yeah, I would just type some stuff on a Google Doc and then save the doc and then just hit send project and upload the document.
Okay.
Y'all know how to use Google Docs, right? I mean, it's free. It's right there. Do y'all use Chrome at all? Is that what y'all are using?
Yeah, I use Chrome. I never used Google Doc before. I will use Word. But I think
oh yeah, you can use Words too.
Yeah,
I don't have Word. Because,
okay.
So yeah, the way I would do it is just open up a document. I would go here. And I would paste it here, and then I would just type the answers underneath it.
Okay.
Save it and upload it. That's how I would do it.
Okay.
All right, are y'all good for tonight?
Yeah, sure, absolutely. Thank you.
Y'all want to go another 3 hours and do another?
I'll be snoring.
All right, y'all. It's been great working with you, getting to know you. I will see you the day after tomorrow. Do y'all have any questions for me?
Thank you very much.
Oh, real quick, I sent out a message on Slacker on connecting us 3. So just go on Slacker and reply, and we'll be in contact through there.
Awesome.
Okay.
Will do.
Yeah, so I did a message too, so just ignore that, Abu. And then do the one that Yuki sent right now.